Okay guys, I would love to do this in person, but I cannot, right, because you're at home and I'm here. So therefore the best I can do is try and act as if you were in class and let's go through this. Now, what we're doing today in this sort of 10 to 15 minute video before you guys crack on is looking at bearings and how that can be related to trig questions. As I said, paper 3, the last question, apart from 2 people in the class, was answered poorly because you don't know how to interpret bearings. Well, this was the question. At the end of the video, we'll go through this question. Okay, so therefore, you at least have something tangible to say, well, I didn't know it then, I know it now, and I'll give you practice questions as well, just like this. Okay, so it's very important. Right, I won't go through this in detail yet, I'll do it at the end of the video, but the idea is that it's combining bearings with the cosine sine rule that you already know. Alright? So let's start with the very basics. Bearings, there are 3 rules. There are only 3 rules. Now it is literally a grade 4, grade 5 maximum topic. Bearings. Alright, that's it. 3 rules are this. Needs to be 3 digits. Now what I mean by that, and it sounds a little bit silly, but what I mean by that is, if I can find my pen, if they said it's at 123 degrees, that's fine. But if it said it's at 23 degrees, you cannot write that as a bearing. A bearing must be 0, 2, 3. It must be 3 digits. Okay? If it was a 7 degree, it would be 0, 0, 7. Okay, that's how it works with bearings. 3 digit bearings. Right, next one, it has to measure from north. Whenever you get a bearing, draw a north line immediately. That is the rule. Whenever you get a bearing, have a north line immediately. And the last one, always got to be clockwise. We always measure from clockwise. Now, a few of you, I hope not many of you, are going to panic about what's clockwise, anti-clockwise. I do hope not. Just look at the clock, firstly. But clockwise, if I was measuring, for example, this angle here, clockwise would be from here, clockwise goes this direction, so it would be like that. Okay, it would not be like this, that's anti-clockwise. Clockwise would be that direction there. Now, as long as you know those 3 rules, you should be fine with bearings. Now, they're written in a slightly weird way, so I will go through that now with you guys. Alright? So we said that already, the 3 bearings, the 3 rules. So therefore, if I was to say, what's the bearing from north to east, you'd say, right, from here, north to east, so it would be that there, so it's going to be 90 degrees, because it's measured clockwise. With 0, 90, obviously it's 3 digits. From north to south, would be here to here, so it would be that whole one there, so that's 180. From north to west, you cannot go that way, it's clockwise we must go, so therefore from north, we go all the way around to west, so it's 270. And then north to northeast, northeast you know is here, so therefore it would go from here clockwise to there, 45 degree angle, but you must say 045 because it is a bearing. Alright, so therefore they're the very basic parts of bearing. Now, one thing I need to say, if it is to scale, if the drawing is to scale in the exam, and trust me, if it is, it will be in the first 5, 6, 7 questions maximum. They will never give you a to scale bearing later on in the paper, then fine, use a protractor, measure it that way. Very unlikely though, what normally happens is it's not to scale and you have to use your numerical understanding of what's going on within the question instead, okay? So, a couple things. Right, the way it's written makes it feel more difficult than it is. So it says, the bearing of P from Q. Let's look at that. The bearing of P from Q. Right, the way it's written is baffling to us, but the most important part is where it's from. Where it says it's from, that's where we start. So it says it's from Q, great, we start at Q. I know P was mentioned first, I don't care. It's from Q, so we start at Q. It then goes north to Q, and we want to measure the bearing of P from Q. So therefore it would be that angle just there, which is 052, because it's clockwise measuring from north. Now, if the question said, what's the bearing of Q from P? So from P, so we start here, it couldn't just be 50. Of course it couldn't, because that's not clockwise, that's anti-clockwise. So you must measure clockwise from north, so it'd be that whole angle there. Now you know that altogether that'd be 360 around the point, so that's going to be 50, which means that must be 310. So when they ask what's the bearing of Q from P, it's going to be 310 instead. Alright? I'd love to get your feedback here, but obviously I'm talking to a video camera, so it's not going to be as easy. Right. Here, calculate the bearing of Q from P. So from P, here, of Q. Now you know if it's from P, we start here, we want it to Q, therefore we've got to work clockwise, so we actually want that angle there. Now the difference between this question and the last question is that we don't know this angle yet. So this is where we need to use our basic parallel line rules. Alright, that there is two parallel lines creating a C shape or a U shape, which therefore makes it a co-interior angle, which both add together to get 180. So therefore that, if that's 120, this must be 60. And if that is 60, you know that angle there must be 300, because they add up to 360. Alright? And that is what I've basically gone through there, so it's fine. Okay. This can only work, probably, if you pause the video after each of my examples here and shout out at the screen what you think it is, because otherwise I'm just talking to myself. Right, so here, the bearing of P from Q is, okay, the answer is 0.45. Alright, there you go, it's getting bigger, which proves it is. Okay, the bearing of P from Q is, and it'll be 150. The bearing of Q from P is, so look where it's from, it's clockwise here, needs to go to Q, so therefore it will be 310. The bearing of P from Q, so of P from Q. Right, if you've unpaused it, P hasn't got a north line. You must draw a north line on P. Alright, otherwise the bearings don't work. Of P from Q, so from Q to P is going to be 0.60. And here it says the bearing of Q from P, of Q from P. Again, because it's from P, you need to go here, clockwise to Q, 100, that must therefore be 80. These add up to 360, so it's going to be 280. Okay? And that there is the simplistic way of teaching bearings and really all you need to know. So now let's go through two examples right now together. Then what I'll do is I'll put it on the board, some other questions, answers already there, and I'll also send around the PowerPoint anyway, so therefore you can work on it yourself if you need to. So A is on a bearing of 60 degrees from B. What is the bearing of B from A? So I look, A is on a bearing of 60 from B. So therefore we start, because it's from B, we start at B. So I'm going to do that, and I'm going to put B. So A is on a bearing of 60 degrees from B, which means I start at B, and it's like 60 degrees. It doesn't really matter where I end. It doesn't tell me how far, it just tells me what the angle is. And that we'll label as A. And therefore this would be 60 degrees, because A is on a bearing of 60 from B to A. What is the bearing of B from A? So it's basically saying, alright, you've drawn down what I've written in my first sentence, how can you use that to help me with the second sentence? What is the bearing of B from A? So you start at A because it's from A, and you go all the way around here. That is the angle they're looking for. That's the bearing they're looking for. So you'd work, say, well, co-interior angles, that's fine. So that adds up to 180, so that's 120. And then around the point, so 360 minus 120 is 240 degrees. And therefore that would be the bearing of B from A. Okay, let's look at this one here. A ship travels 32 miles due north. So therefore I'm going to draw up here. So a ship travels 32 miles due north. I'm going to label that 32. Okay? And another boat travels 60 miles on a bearing of 270. So therefore 60 miles on a 270 bearing. So it starts here, 90 would be here, because it's clockwise, 180, 270. So actually we're looking at a situation like that. 60 miles, so I label that 60. What is the distance between them? So therefore I join it up. And what you've noticed, guys, is because the bearing was 270, that means that that leftover bit must be 90. And therefore you just use simple Pythagoras in order to work that out. Do you know that's 60 and that's 32. A squared plus b squared equals c squared. I'm not even going to do that for you because you know how to do it. Okay, so that's an example of how bearings can be combined with, let's say, Pythagoras or even SOHCAHTOA. Okay, if they gave you an angle, another angle there. Right, but you're probably thinking, alright, this man's been talking a while, and by the way, you can try this on the PowerPoint if you need to, and there's answers there obviously with the PowerPoint you've got, but you're probably like, well, what about more complicated questions? Right, we're going to go through two of them. Okay, this one doesn't, by the way, this one coming up here, this doesn't involve cosine or anything. The next one was your exam question, that certainly does, and a lot of the questions I'm going to give you for today's task and possibly tomorrow's, if it lasts long enough for that, will be on questions which involve trig. Okay, let's look at this. I know it's quite small writing, so therefore I'm going to be as clear as I can here. The diagram shows the position of each three buildings in a town. It's the art gallery, hospital, cinema. The bearing of the hospital from the art gallery is 072. North 072, so there you go. And remember how it's written? Hospital from the art gallery, so that's where it starts, and that's why the bearing starts there. The cinema is due east of the hospital. So straight away you know that's 90 degrees, it says it there anyway. The distance from the hospital to the art gallery is equal to the distance from the hospital to the cinema. So all that's basically telling you, that's isosceles triangle. Work out the bearing of the cinema from the art gallery. Where are we talking from? From the art gallery, we want to go to the cinema. So we're starting at the art gallery and we're going clockwise to the cinema, which is going to be that angle there. So they've given us 72 here, but we need that whole angle because that will be the bearing to the cinema. Okay, so our objective here is basically to find that little bit of the angle there. So I'd look and I'd say, okay, actually firstly try it by yourself, so press pause if you want to. Okay, for those that did or those that didn't, I'm going to keep talking. Co-interior angles, so I know that is going to be 180 minus 72, which is 108. I then also know that angles around a point add up to 360, so if that's 108 and that's 90, that's 198, and then 360 minus that, a lot of you are probably shouting at your screen right now, but I'm getting stage fright, so I forgot how to do basic maths. So 360 minus 198 is 162, so that's 162. Now you know obviously the isosceles, so therefore that and that are going to be the same. So 162, 180 minus 162 is going to be 18, and then 18 divided by 2 is 9. So that's going to be 9, and that's going to be 9. And therefore we've actually got where our answer needs to be now. The bearing of the cinema from the art gallery is going to be whatever 72 plus 9 is, which is 81. However, do not stop there. Yes, we've got the angle we're looking for, but it's about bearings. And therefore you know one of the three important rules of bearings is 3 digits, so therefore our answer will be 081 degrees. Okay? Right, I'm now, you're probably bored of my voice as normal, but I'm going to do one more example before I want you guys to do worksheets yourself. Okay? And that example comes with this. Right, this is what you were given in the exam, and so I will go through it properly now. I will do that now. Okay, I actually, just to make sure I didn't embarrass myself, worked it out first on here. So if you see me copying and you think it's because I've already worked it out, I'm copying that. Okay, it says, Barston is 8 kilometres from Acton on a bearing of 037. Okay, Chorlton is 9 kilometres from Barston on a bearing of 150. They've drawn that out for you, that's fine. Find the bearing of Chorlton from Acton. Where it's from is where we start. So there's Acton there. Okay, now it wants from Acton basically to Chorlton. Now they haven't actually got a line there yet, so you've got to draw in your own line. So A to C is a pretty horrific line, which even in a video I'm not happy with. So therefore, let me do that again. Isn't much better, but we'll work with it. Okay, when they're saying here, find the bearing of Chorlton from Acton, we start at Acton, we want to go to Chorlton, so therefore the angle we're looking for is that whole one there. That's our aim here, that would be our answer. So now you just look and say, what do you know about this? What do you know about this shape? Well, firstly, you know that these are co-interior angles here. Whenever you've got bearings, always look for co-interior angles. So I'll do 180, take away 37. So 180 take 37 is 1, 4, 3. Alright, I then look and say, well, I can easily find that angle as well now, because angles around a point. So therefore that is going to be 67. Now once you've got that, you're good. And the reason why you're good is because you now think, well, I know how to use sine, cosine, or whatever I need in order to find the rest of these missing angles and lengths. So I say my main objective here is to find this angle right now. However, having that length and that angle doesn't actually help me in my next step, get that. So I need to get more information. I would say in my head, I need to find that length there. Because once I've got 3 lengths, I can work out the missing angle. That's my mindset. So what I would do, I would probably redraw this. And I would go that, a lot of you might be working ahead of me now because you might see exactly how to do it. 8, 9, you know that's 67. Okay, we want to find this angle here. So it's the cosine rule. A squared equals b squared plus c squared minus 2bc cos a. So therefore this would be our a in this case because we're looking for it. This is going to be our b, this is going to be our c. So a squared equals 8 squared plus 9 squared minus 2 times 8 times 9 times cos 67. And so once I've done that and then I've square rooted it, a equals 9.419, etc, etc. Now obviously I would keep that whole number there, I'll keep the whole thing because I don't want to round up too early. So for the sake of this, I'm going to put this here, 9.419, blah, 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 blah. Right. I've now got that, so now what I've got to do, I've got my 3 lengths, I can find my missing angle now using the cosine rule again, but the different angle kind. So because A equals b squared plus c squared minus a squared over 2bc. Now do not use the ABC from here because that will be labelled wrong. You want to redraw it again. Here, we've got 8, we've got 9. We know this is 9.419, whatever now. Okay, you want to find this angle here. So this is going to be our x. So realistically, to use this will be our capital A, which means that this needs to be little a, this needs to be b, and this needs to be c. So now substitute that in. So it'll be cos x equals, and then 8 squared plus 9.419 squared minus 9 squared all over 2 times 8 times 9.419. So cos x was 0.4759, and then I cos to the minus 1, so x would be 61.6 degrees. So therefore you know that's 61.6 degrees. At this point I knew because I was adding it to 37, I don't need to, I can round it to one decimal place now, and the reason why I'm adding it to 37 is because you want to find the bearing of Chorlton from Acton, which is all the way around there. So I want that whole angle there. So I add them up, 37 plus 61.6 equals 98.6. Then the final step is that it's about bearings. So therefore you want 3 digits. Now the fact there's a point there still counts as 2 digits. So we need to go 098.6. That's our final answer. Right, so that was the last question worth 5 marks on a real exam paper. Alright, this is stuff we can do, we just need to understand the language of bearings. So please today, and possibly tomorrow, do the work that I've set using this language and see if you can when you could have got it. Alright? Best of luck.